In the previous few episodes, we built a programmable fuel rack limiter and a linear boost controller valve for our 719cc AMR 500 supercharged Kubota diesel-powered Honda Insight. The main purpose of these custom-built gizmos was to eliminate a puff of dark smoke from the exhaust when the car accelerated. I'm sure it would be helpful for some folks to understand why the engine was behaving this way. Well, first of all, the fuel rack limiter screw was adjusted a few millimeters past the factory calibrated setting, and that simple modification, along with the supercharger, provided an enormous increase in power. Power that we really needed in order to safely drive this car on the road. So the bottom line is, the root cause for the momentary puff of smoke can be traced back to the internal governor on the engine, sending the fuel rack to its maximum position for a few moments when the throttle was depressed. Well, we were overfueling the engine before the pressurized air from the supercharger could help the fuel burn more efficiently. By adding the programmable fuel rack limiter and the boost controller, we were able to change the sequence of events, and now when the accelerator is pressed, we instantly feed the engine boost from the supercharger. Then we allow the fuel rack to start moving past its factory calibrated position. Don't panic. Remember, this is a diesel engine and not a gasoline engine. Sending boost to the engine without adding additional fuel is perfectly fine. You see, lean-burning diesel engines love boost, but do the same thing on a gasoline engine, well, you're going to have some problems for sure. Anyway, once the intake manifold is pressurized, then we allow the fuel rack to move past its calibrated settings, and we get a very nice boost in power. Now, the smoke issue really wasn't a big deal for rural driving. However, we wanted to try and drive this car in an urban environment and decided to gin up a gizmo or two in order to stop the puff of smoke from happening. Today, we're going to fully road test the car and see if our devices have hurt the already pathetic performance of the little diesel engine, or does it actually help? You see, in theory, we should really see an improvement, but that's just a theory. Also, we'll be adding an exhaust gas temperature sensor to our computer system, and the main purpose of this sensor is to automatically prevent serious engine damage. As it turns out, holding the accelerator to the floor for longer than a minute will in fact melt the pistons on this completely stock Kubota D722 engine. So we're going to add the EGT sensor and a few lines of code, because power is good, but melted pistons are bad. Before we get started, well, the Arduino-based microcomputer is kinda looking a bit messy.
That escalated quickly.
Yep, believe it or not, this pile of junk works, and it's been trouble-free so far. But I think it's time to mount these parts in a proper enclosure. Fast forward a bit, and the new enclosure has been partially assembled, and now it has 3D printed mounting points for all the major components. Now over here is something different. It's a buck boost power supply that one of our subscribers sent to the P.O. box. Thanks, Dave. Now over here is yet another voltage regulator. This guy's job is to supply a clean 9 volts to the Arduino. You see, previously, this whole computer system was powered by a small 12-volt external battery. Well, the next step is to draw power from the car's electrical system, and we need to filter the power in order to do that. Let's take a few moments and talk about the exhaust gas temperature sensor that we're going to add to the system today. A simple low-cost meter like this is perfect for measuring the exhaust gas temperatures, but there's no way to get the data from this meter to the Arduino microcomputer. Now, I did have a look at several low-cost solutions, and I wasn't really happy with the performance of any of this crap. Well, apparently there's a reason why this stuff is cheap. Now, this guy is something I've had in my box of goodies for a long time, and I really didn't want to use it. Well, first of all, it's an expensive gadget, and as I recall, I gave over $100 for this thing a few years ago. And second, it's a 4-channel K-type thermocouple amplifier, which is overkill because we only really need one channel. Basically, this thing is too good for what we need, but given that the alternatives suck, this is probably the cheapest and most reliable solution that's available. Anyway, this gizmo's made by playingwithfusion.com if anybody's interested. It appears to be well built and uses genuine Omega K-type connectors to ensure the continuity of the signal is not affected by introducing different alloys into the thermocouple circuit. Anyway, I want to keep this sensitive analog circuit board away from the electrically noisy stepper motor controllers, so I 3D printed a custom enclosure for it. Since we're only going to be using one channel, well, there's only one opening in the enclosure to make that necessary connection. Of course, we had to put the Robot Cantina logo on the cover. Now this is a one-of-a-kind part. Fast forward a bit, and now we're making some progress. We have the completed enclosure, the LCD display, the manual override panel, and the thermocouple amplifier box. Now, as you can see, this new enclosure is a lot bigger than the old enclosure, and that's fine. You see, as I continue to experiment, I want the extra space, so making changes is a lot easier. Now, if all goes well, down the road I can use smaller components once I've established the system works as expected. I reckon all this junk could be shrunk down to the size of a deck of cards, but that's a project for another day. Now, for the purpose of troubleshooting and tuning, the LCD display and the manual override panel have been retained. Both of these devices have made tuning the system so much easier. Remember, I have to tune all this junk by myself on the side of a deserted road here in rural Kansas. So, nope, we ain't got a $2 billion research facility. It's just me with a pen and a notebook. The buck boost adjustable voltage regulator was supplied by a channel subscriber, and it's proven to be very helpful. We set the voltage output on this guy to 14 volts, and what that means is this buck boost regulator will supply that voltage even if the supply voltage drops down to 6 volts. The reason we're running a higher voltage is the stepper motor controllers really want 13 or more volts to operate correctly. Now, inside the enclosure, everything's nicely laid out for easy maintenance and modifications. On the back side of the enclosure, we have an exhaust fan that provides a nice draft to keep everything at ambient temperature. Summertime here in Kansas can be brutal, and typically the interior of this car hovers around 95 degrees Fahrenheit, and that's with the driver's side window fully open. I reckon we need to see if this repackaged hardware and the updated software have made a difference. Well, you fix one mess and you wind up with another. Meh, this stuff looks suspicious, so we're going to avoid interfacing with the police, that's for sure. Okay, so a quick explanation of how this stuff works. Over here on the display, we have the drive mode, and that tells me what part of the software is being executed. The different modes are idle, drive, accelerate, cruise, accelerate plus, which adds a little bit more fuel, and max power. Occasionally we'll get the EGT trim if the exhaust gas temperature gets too high. Now if I turn this knob clockwise a little bit, that'll disable the automatic functions and I can manually control the boost and the fuel rack. The manual controls are for developing software and we won't be using them today. So if I press down on the accelerator, you can see the computer changes modes. So the accelerator position determines what mode is selected, and that's pretty much it. Keep in mind, this is a mechanically fuel-injected diesel engine, and there's very little I can do to influence how this engine runs, other than limiting the fuel rack position and of course how much boost we feed the engine. Alright, let's light this candle. The fuel tank's been prepared for a fuel economy test, and I intend to put a lot of miles on this car today. So a lot of folks are interested in the fuel economy, and I agree that's an interesting data point. However, today I want to drive as much as possible to validate that the system will work reliably. Now, off camera, I've spent hours bench testing everything, including verifying that we won't have any problems due to the summer heat. It's hot inside this car, and that was definitely a major concern. The good news is, this system's very robust, and I don't expect any problems. So in a previous video, we did some basic testing. However, since then, I've done a lot more software development, and the new code has updated formulas that have been tailor-fit for this engine-transmission combination. Today, we'll just drive the car like a normal person would, and there'll be no effort to conserve on fuel. The hypermilers hate it when I do this, but in order to make this car better, I need to accumulate real data from actual real-world driving. Okay, well let's test the exhaust gas temperature fuel trim feature. This little display is going to be hard for a lot of you folks to see, so I'll zoom in on it. I'm going to do a hard acceleration, and hopefully the software will detect an unsafe condition where the EGT exceeds its preset limit and automatically pull back on the fuel rack. And yes, the fuel trim feature works. Right now the trigger point is set at 875 degrees Fahrenheit, which is about 200 degrees lower than where I would normally set it. It's unknown how hot this engine will run since it wasn't built for forced induction. Now, a Kubota technician did contact me a while ago and told me the D722 engine's okay to run at a constant 950 degrees Fahrenheit, and I can go above that for a short time. So just to be safe, we'll start off with a lower cutoff point. It really doesn't make sense to push this engine beyond its limits because this channel actually can't afford to buy another one of these engines. So it's been about 4 years since I started making videos on YouTube, and I'm sad to say I lose money on almost every video. Sure, the videos generate revenue to keep the projects going, but even at 150,000 subscribers, and thank you everyone for subscribing, well, we're still not able to expand past simple projects, and we really try to stretch our dollars as far as we can. My brother Duke keeps track of the expenses, and he recently told me that in 2023, I earned an average of 25 cents per hour to write, direct, produce, narrate, and edit each video. And of course, I also do all the engineering and fabrication. If I didn't love making these videos, well, I would have quit a long time ago, that's for sure. The good news is, this is the most fun I've ever had, and plan on continuing making these weird projects. If you want to help support this channel, please consider subscribing. Subscribing is free, and it lets YouTube know this is the type of stuff you want to see. Now, starting next week, we'll also have our Patreon account finished, and that'll allow a few of you folks to support the channel in a different way. I'll announce how all that works in the next video. Also, for the next month or so, we'll be releasing a video every 2 weeks. That way, we can focus on making longer and more interesting videos. Plus, it's really hot in the shop, and it seems like it takes a lot longer to get stuff done. Today, we're trying to keep the vehicle speed at or near 55 miles per hour, which is easy for this car to do. Now, 55 miles per hour is a reasonable speed, and it also happens to be the speed limit of most of the roads we travel on. So there you go. I think in a future video, we're going to try a few other things like going faster and going slower and see how that affects the fuel economy. This car is always full of surprises, and you never know what it's capable of until you try something different. The traffic today seems heavier than normal, but I have some business to take care of, so I reckon it's a good time to pull over. Yep, sometimes it's good to get out and stretch the legs, if you know what I mean. What a beautiful day in paradise. Alright, let's continue our journey. So it's a bit hot inside the car, and to make matters worse, the passenger side window will not open. Now, I wish it was a simple problem, but a few years ago I removed the gizmo that makes the window go up and down to reduce the weight of the car, and now the window's permanently closed. That may sound extreme, but keep in mind at one point this car was powered by a 212cc Harbor Freight engine. Yep, with only 212 cc's on tap, extreme weight saving measures are necessary. But now we're living in luxury with 33% more engine. So the car seems to run fine, and up ahead I have a decision to make. We can continue going forward, or we can get on the expressway and see what this car can do. Well, just for fun, let's take the Expressway.
Fasten your seatbelt.
So right now they're doing road work, and that will sort of give us a better chance of getting this car up to speed without impeding traffic. I can't believe I'm actually doing this. So when the EGT fuel trim goes active, there's a reduction in power. The good news is we still have plenty of power, and if I keep the accelerator where it's at, the full power will come back in a few moments. So what that means is the car can be driven at full throttle indefinitely, and the pistons will never get hot enough to melt. So now we're actually going up a hill, and the car is still accelerating. This is fascinating, and I'll tell you why. The normal Honda Insight that we have doesn't like going up this hill in 5th gear, and that car will actually slow down, especially with the air conditioner on. Meh, you can't see it, but over to my left is a Razor looking for speeders. Well, I ain't speeding, but I don't want to pass that guy at 70 miles per hour with the 3-cylinder 719cc supercharged diesel at full song. So, I'll pretend to be exiting the Expressway. I think that's probably a good idea. Okay, well, our little detour has brought us into the big city in any town, USA. Let's see if this car blends in. So far, so good. Looks like the stealthy anti-puff of smoke gizmo is working, and there doesn't seem to be any concerned citizens dialing 911. Let's get out of here just in case. Well, we're back at the Expressway, and the cop is still there. Well, this is a fine mess we're in. I can't accelerate back onto the Expressway at full throttle because the noise this car makes. But I can cross the highway right in front of the cop, and I can do that quietly. So let's see what happens. Nothing to see here, just a cobbled together silly looking car with a supercharged diesel engine from a refrigerated semi-truck trailer. And that's how you avoid the cops. Well, the road test goes on for hours and hours, but here's what I learned. So on the first day, the car covered 104 miles without any issues. Now, I didn't make any attempt to drive the car in such a way as to conserve fuel, other than keeping the speed at around 55 miles per hour. Anyway, the car delivered 76 miles to the US gallon, which I believe is the best it's ever done. Overall, the car drove fine, and I believe it's capable of keeping up with city traffic, which is a test for another day. Now, on the second day of testing, the car covered 125 miles, which is quite a bit of distance to go without air conditioning. My only complaint was on the second day, something on the exhaust system seems to be rattling. It happens once in a while. Anyway, once again, this car delivered a higher than expected fuel economy, and we were able to measure 78.6 miles to the gallon. The method that we use to determine fuel economy has been discussed in previous videos, and it's extremely accurate, so I have confidence in reporting those numbers. Now, that's all very interesting, especially since this is not a fuel economy project. I reckon that may seem confusing every time I say it. Remember, our focus is on the effects of putting a supercharger on a tiny diesel engine, basically just for fun. This was never intended to be a serious car. However, after the past few days of road testing, I'm officially declaring this to be a reasonable car. But, as most of you folks know, if an LS would fit, well, that would be a better choice. And speaking about an LS, let's see how fast this thing can accelerate. Let's see if this little diesel engine has anything left to give. For this 0 to 55 will be at max power, which translates to 100% of what the injector pump can deliver and 100% boost. The time to beat is 20.06 seconds. Well, that was close. The computer switched to the EGT fuel trim right after the 55 mile per hour mark. Now in this run, we gave the engine more fuel than we ever have before, and it looks like this engine's maxed out and it has nothing left to give. The problem could be we need to make more boost because the injector pump is now at 100%. Now keep in mind the fuel trim went active at 875 degrees, which is what we programmed it to do, but we could have let it go much higher. Unfortunately, I don't think that would have made a difference. You see, the car already passed the 55 mile per hour mark when the EGT trim kicked in. I think I want to try a few more things to this engine, and it isn't over yet, but that's enough for today. So this car still has plenty of experiments left in it, and it'll be interesting to see what improvements we can make. The fact that we have a microcomputer on board means we can make major changes without ever turning a wrench. Right now, this car is tuned to be user-friendly and easily drivable. But I still have a few cards up my sleeve, and we'll explore some alternative tuning soon enough. I certainly had a lot of fun today, and I hope you did as well. We'll see you next time. Until then.